Good old Anne. So this wants you to find the net force exerted on charge 3. What I'm going to do is I'm going to find the force exerted by charge 1 on charge 3, magnitude and direction. I'm going to find the force exerted on by charge 1 on charge 3. I'm going to find the force exerted by charge 2 on charge 3. Why don't I care about between 1 and 2? Because the question didn't ask for that. I realize 1 and 2 are also exerting a force on each other. They didn't ask for that. They want to know what charge 3 is feeling. So that's going to end up being K, Q1, Q3 over, I'll call it R3 squared. That's going to be 9 times 10 to the 9th. Q1, 2.5 microcoulombs. I don't need to put the negative in. The negative is going to be used to help me figure out whether it's like repel or unlike attract. Q2, 2.4 microcoulombs. All over, 1.2 plus 1.8. Don't forget the squared. The force between 1 and 3, magnitude, is going to be 9 times 10 to the 9th, 2.5 times 10 to the negative 6, 2.4 times 10 to the negative 6, divided by 1.8. Don't forget the squared. I get 0.01 and then 6 repeating. Is that right for the first one? Direction. Which way does charge 3 feel a force because of charge 1? Are they like or unlike? They are like charges. So it's going to feel a force to the right. Repeat between charge 2 and charge 3. It's going to be K Q2 Q3 over R2 squared. It's going to be 9 times 10 to the 9th. Q2 is positive 3.2 microcoulombs. Q3 is still 2.4 microcoulombs. All over, 0.6. Don't forget the squared. I can just backspace and edit with a bit of cleverness. I think I can change that to a 3.2, and I can change that to a 0.6, and I get 0.192 newtons. Direction, which way will charge 3 feel a force because of charge 2? They're unlike. They're going to be attracted, so charge 3 would feel a force to the left. Now I need to add these vectorially. Are they in the same direction? Nope. So I'll call it F net, or you know what, if I want to be really basic, it's the force on charge 3. I'm going to go 0.192 left minus 0.016 repeating right, 0.192 minus 0.01, and my high-tech 6 repeating is just to do a few extra 6s. And I get 0.175 newtons. Is that right, folks? Direction, who won? Left. In other words, if I was holding all 3 of those charges in place and I suddenly let Q3 move, which way would it accelerate? Left. Is that right? This is worth 7 marks, I think. If you got it right, you got 7 out of 7. Otherwise, I would give you 1 mark if I saw that, 1 mark for the numbers, 1 mark for the answer. What I would actually do is I would do half mark for the answer, half mark for the direction, 1 mark, 1 mark, half mark for the magnitude, half mark for the direction, half mark for the magnitude, half mark for the direction. Your 7. Ooh, electric field. So electric field, and we're running out of letters because right now that's electric energy from yesterday. Oh, nope, now it's electric field because now it's a vector. That's going to be KQ over R squared. I guess I'm going to find the electric field from charge 1, which is going to be KQ1 over R1 squared. It's going to be 9 times 10 to the 9th. Q1, 5 microcoulombs. Again, I don't put the negative in. 1.5 squared. 9 times 10 to the ninth times 5 times 10 to the negative 6 divided by 1.5. Don't forget the squared. Is it 20,000? Is that the first magnitude? That's the magnitude. Units, newtons per coulomb. Direction, we ask which way would a positive charge right there want to move if it could because of Q1. I think it would get pulled to the left. Why a positive? We had to define the direction somehow because unlike gravity, in electricity, stuff can fall up. So we define the direction in terms of a positive charge. Repeat, this time for electric field 2. It's going to be KQ2 over R2 squared. It's going to be 9 times 10 to the ninth, 3 microcoulombs, all over 0.85. Don't forget the squared. Oh, this is going to work out to a yucky decimal. Oh, Dueck. Just backspace and edit. Change the 5 to a 3 and 0.85 squared. Do you get 37,370 and change? 37,370 newtons per coulomb. Direction, which way would a positive sitting right here want to move because of Q2? You know what? Also to the left, this time because like charges repel. How will I add left plus left? I think I'll just add them. So the electric field is going to be 57,400. Is that right? 57,300 newtons per coulomb. Left. Is that correct? No? Yes? I got some nods. Good. If you got that, 7 out of 7. Otherwise, I would go 1 mark for that, 1 mark for that, half mark for that, half mark for the direction, 1 mark for that, 1 mark for that, half mark for that, half mark for the direction, half mark for the magnitude, half mark for the direction. So that quiz is out of 14. Can you give yourself a score out of 14, please?